I'm delighted to be introducing the next session. We have Anne Neuberger here for a fireside chat on AI and national security. I'm delighted to be moderating this conversation today. I'm Janet Egan. I'm a senior fellow at the Center for a New American Security. And we're going to be talking about how we can bridge the technical and policy environments when we're talking about AI progress. So, Anne, you've been working at the technology and national security intersection long before AI was dominating every panel at every conference. From your vantage point, what are the enduring challenges that haven't really changed? And what's new and really breaking the mold when it comes to AI?
Fantastic. So, good morning, Janet. It's great to be here with you. It's great to be here with everyone here. A couple of thoughts on that. I would say one thing that hasn't changed is exactly what you hit on. Technology moves far more quickly than policy or the law. Or as such, we end up with technology adoption or some of the questions that were talked about in the prior panel moving out before law or policy has caught up. And for me, I think about this a lot in the context of I was NSA's first chief risk officer after the Snowden media leaks. And at that point, that issue came up in stark relief, right? The technology had changed. We were in a digital world where adversaries and terrorists were using the same technologies as everyday Americans and civilians around the world. And what the law and policy should be around surveillance in a democracy hadn't necessarily kept up in what the technology was doing. And when all of that became public, I think many people were surprised by the gap between them. So I think as we look at AI, which is such a transformative technology, thinking about, and that's why I'm so excited to be here and to have seen this set of discussions you had, thinking about how we advance policy and law, at least in lockstep as much as possible, with technological advancements is really important.
So, throughout the conference, we've been talking about this tremendous pace of AI progress, like from capabilities that we're seeing here today to what's just around the corner in a year's time. And so, where do you see the highest value applications for US national security? And are we on track to capture them, and what's getting in the way?
So, from a national security perspective, some of the toughest issues we deal with is just the massive increase in data, all different kinds of data, sensors from different kinds of platforms that collect different kinds of intelligence information, from voice to RF to images, and the need to process them quickly and to make sense of them quickly. So, there's the opportunity to really produce more, faster, and better intelligence via synthesizing of all of that information far more quickly. That's one example in the national security space. I think a second example really is self-healing cyber networks. Many of us are deeply concerned about the advancement in AI-driven cyber capabilities in terms of finding zero-day vulnerabilities. As we all know, finding zero-day vulnerabilities is the first step, whether you're an attacker or defender. So quickly hooking that to the second step as a defender, particularly for critical military, nuclear, and other systems, so we can self-heal them is key. In a prior role, I was responsible for the security of nuclear command and control. NSA obviously builds the encryption of those systems. They were built in the 60s. Quite frankly, as we think about advancements in cyber attacks and capabilities, those are the systems that come to mind first when I think about the need for self-healing systems driven by AI. And to your point regarding the barriers, as the technology, particularly in AI, we see the capabilities, we see what's possible. We also know that the systems can be fragile. So truly understanding them enough to really utilize them and determining when is it safe enough to deploy in a given space? How do we maintain adequate oversight so if something unexpected occurs, it can be addressed, I think is the crux of the core challenge and the barrier, which really the best way to address is use by a set of people who understand the systems, understand the AI, and understand traditional approaches we've used for oversight of rapidly evolving systems.
Can I prompt you to talk a bit more about the traditional processes we use for the oversight of these systems? We heard it in the prior panel that how we oversee this fast-moving technology is like an open question and will cause new challenges. What are the lessons you've learned from the past on that particular issue?
There's a really interesting report that Scott Sagan at Stanford did after a series of accidents at nuclear power plants. And the reason he did that is because when you think about advanced oversight systems, including multi-step and self-healing systems, nuclear power plants come to mind, right? Because these are systems where the degree of risk tolerance is really low and systems have been modeled and thought through. And he looked at a couple of specific accidents that had occurred in the context of how we think about autonomy in weapon systems. That was why I was reading this study then, to better understand as we think about delegating autonomy to weapon systems, whether it's radar control systems, whether it's targeting systems, understanding how much we need to understand them and what degree of oversight and what is the interplay between systems and human oversight. And one of the core takeaways was, as systems become very complex and as the natural technical parts of those systems that are meant to address risks become built in and not understood, in some cases the human oversight was disrupting the system level oversight, and that interaction is in some cases what caused the breakdown. So the takeaway from that, I think, is to both think about and understand. I'll use a particular field because otherwise it's theoretical. So when we think about, for example, what is happening in cyberspace, right? The degree to which AI-driven systems can now identify at scale zero-day exploits and can be potentially exploited at scale. From a defense perspective, we need to be able to, at scale, also find misconfigurations, find vulnerabilities, and address them. So I think the key piece is to ensure that as things are done, the decisions that are made are documented so somebody can review them, setting up the left and right boundary space of decisions that we understand so we can see that they stay within certain limits and explore when new ones are needed, can also be a way to look at humans being both in the loop but also observing to enable the speed we need.
So it's really exciting to think about what's going to be possible with AI enabling potential better national security for the US and its allies. A question I had for you was on a more sobering note. So, what are the emerging risks that keep you up at night, and what should we be doing about them that we're not?
I think the opportunity for recursive self-improvement is an emerging risk because while it's a powerful approach, it can lead to systems whose capabilities we don't really understand. So that is one of the areas that, as we heard about in the prior talk, the lab simulating and understanding those capabilities, the interplay between the frontier labs and safety areas, who can test those in the context of domains we worry about, from nuclear to bio to cyber, is really important.
Let's talk about China. So, we're seeing this emerging fast follower dynamic where the US is pouring massive amounts of investment into progressing the frontier, and China's a few months behind through methods like adversarial distillation. How should the US think about this fast follower dynamic and the competitive dynamic that introduces? And what would your advice be on this area?
I think there's been a lot of focus on who's at the cutting edge. In my mind, we need to combine that focus with who's leading in adoption, particularly in areas of the economy that are game changing, such as drug discovery, or areas of national security, like advancements in military autonomy that are potentially game changing in fast moving conflict. So I think sometimes we focus a bit too much on, who's one step ahead, when, to your point, through distillation, it really is one step ahead. One can distill advances in another's capabilities pretty quickly. And I think what China is doing in that way, where you have massive American investment that then China distills quickly, is, while challenging for the American approach, it's something that from the Chinese approach is a strategy that from their approach makes sense. I think a statistic that we should be watching strongly that I think gets less attention is 30%, my understanding of global model use, is open source. Of that, 70% are Chinese open source models, which means let's be honest, these were the lessons we learned on all different kinds of technologies. In many places, adoption is not necessarily the best mousetrap, but the best mousetrap that's cheapest. And as a result, open source models are now getting baked in all around the world, baked in economically and in the US as well. So thinking about what our strategy is for that is critical. I think the second part of that is, I recently was giving a talk with the board of a global drug company. And one of the things, they said, tell me about some of the risks you think about. And I said, some of the risks I think we think about, particularly in a post-COVID world, is where critical supply chains for America have moved out of the country. So today, almost all active pharmaceutical ingredients are made in China or India. That matters, both in the context of the it's driving large numbers of drug trials to happen out of the country. 40% of global drug trials are happening in China. So while innovation is still happening in the United States, as we saw in chips, the actual production and manufacturing has moved out of the country. So let's think about the impact of AI on that, right? AI can potentially have an impact. The reason, not to go down into depth on one issue, but I think it's a really important issue, is it talks about national security risks we don't think about in how AI plays out in a given sector and how AI can be helpful in a given sector. Because the cost of drug discovery goes down because you can simulate and develop new molecules with AI models far more cheaply and quickly, that can potentially enable us to think about how we bring back key components of that active pharmaceutical components back to the United States in terms of manufacturing them in a way that's more cost effective. So I think as we think globally from a national security risk, perhaps a more deeper, more sophisticated ways, rather than say who's at the edge, is to say what are the key sectors from a US economy that we need to ensure that supply chains are secure? What has been driving those out of the country, and what role can AI play in ensuring that we maintain both confidence and leadership? And drug discovery, APIs, and other components are just one example of thinking about, I think, national security and opportunity a bit in a more targeted way.
That's a really interesting perspective. I think often in AI discussions, we often just focus on the hard edge of AI capability and think about the areas in which we're potentially losing to China, like robotics. But it's an interesting challenge to think about how can the applications of AI actually start to expedite US growth and greater resilience in some of the areas and critical supply chains where we're dependent.
And like to your point, it's not without risk, but those are the kind of applications where we think about opportunity and risk in more focused ways, which in some ways it's easier to make progress on thinking through those models in more focused approaches that we can then learn from in broader application.
Do you think, like you said, in like the private sector and across government policy issues, and just to probe a bit deeper onto this, like, do you think the US is doing enough on that adoption side at the moment? And what levers can be pulled across the entire spectrum to aid this?
I think it goes back to the first question you asked me, which was, what's stayed the same and what's changed? And I think what stayed the same is that we have a regulatory system that's built up over time. And there are certain controls that are built up over time to deal with the understanding of technology at that moment. Now, as we see the rapid advancements that AI drives, we need a similarly rapid assessment of where do existing regulations address the mark? Where are they a barrier to adoption of really promising ways, both on innovation and, frankly, on addressing risks? And then how do we adjust quickly? I was having, again, an interesting conversation recently with I've gotten people from large national or global health systems reaching out because they want to do AI adoption and they really want to think about enterprise risk in that way. And that's the space we learned so much about in the intelligence community post Snowden, how to think about enterprise risks. These are the conversations I've been having. So in talking with the head of a medical system, he said, we can never recruit or train enough primary care doctors. So we've been looking at, can we do, prescription renewals in an automated way? What should the protocol be to say, how often does somebody need to be checked up to see have they developed a new medical condition? So doing automated prescription renewals would be dangerous for that individual. And I think those kinds of protocols worked across specific sectors. And then the sector comes to the regulatory agencies and says, here are the rules, here's the data and simulations we've done to say we want to leverage AI to make the system better, faster, and safer. Here's what's needed, I think, can bring the laws and regulations of the US into a tighter, more rapid process.
I want to go to now what's been unfolding between the Pentagon and Anthropic. So, the dispute over usage restrictions in military AI has gone from contract negotiations to a supply chain risk designation to presidential commentary, and now is an active federal lawsuit. Now, Anne, you were the first chief risk officer in the NSA following the Snowden leaks. And you had a massive task ahead of you in terms of how do you rebuild trust in like a fracturing between the national security community, intelligence community, and the private sector. And I've heard so much commentary from like innovators and civil liberty advocates and national security practitioners, but I'd be very keen to hear your views on what the path forward looks like. What do we need to do to move things forward in a constructive manner? And what's at stake here?
I really appreciate the question. Um, and actually, noting your affiliation, I worked with CNAS on a CNAS Insight that I wrote on this particular topic. So shout out to CNAS, one of the sponsors of this event. It brought back to me strong memories of a very difficult period in the United States, which was the period after the Edward Snowden media leaks. And as somebody was just commenting to me last night at a dinner, that was the sharp end and really was the sharp beginning to significant tensions between Silicon Valley and DC, in that it highlighted the just difference of perspectives and frankly the knowledge gap between these two communities at two ends of this vast and amazing country. And I think to me at that time, so at the time that Snowden occurred, a month before, I'd been asked to lead an organization at NSA that maintained hundreds of classified work efforts with companies around the world, largely, not large, all related to our intelligence mission. Right? There were sensitive efforts with companies related to largely counterterrorism, counterproliferation of weapons, where companies in some cases shared information regarding these kinds of threats as part of their role in trying to keep the nation, frankly, the world safe. And when the Snowden media leaks occurred, for many of these companies, they felt that the risk was significant and they broke off these efforts understandably. A few months later, I was asked to serve as chief risk officer because we saw both the internal divide at the agency, the degree to which it had compromised the mission of the National Security Agency, as well as the divide between the intelligence community and the American public, as well as with Silicon Valley. And it led me to really three takeaways that I'll say in the context of the Anthropic Pentagon debate. One is, there's one entity we hold accountable for keeping us safe, and that is the national security community, the Pentagon and the intelligence community. After a terrorist attack is missed, after, we had as the FBI said this morning, a Hezbollah-aligned terrorist, drove a bomb-laden vehicle into a Jewish synagogue and preschool a couple of weeks ago. Nobody said, why didn't X social media company monitor his account? They said, where was the FBI, right? Could have had 150 kids, God forbid, killed. So that is the community we hold accountable. And remembering that and that they have that role is key. So the idea that a company like Anthropic in the middle of a war would be approving how their models were used, that doesn't work, right? Because they're not accountable. They don't see classified information about the threat. They're not seeing the larger context around what is happening in a given situation, or frankly, for many here who have worked in the national security community, the cultural training, what people go through in terms of learning the laws of war, proportionality, what's acceptable. So that the overall decisions regarding use of technology in the national security domain should and can, I feel strongly, only be made by those who have access to the classified information, the training on doctrine and law, and frankly, the accountability for keeping people safe. With that said, the technology around AI and its capabilities and its fragility is really uniquely understood by those at the frontier labs. And it's critical that the individuals in the military or intel community making decisions around use understand where it can go wrong, where it can potentially give answers to be more accommodating to those asking, where potentially the systems can break down, where they are fragile. So having a regular detailed technical conversation, detailed technical repeatable between the labs and the individuals both using the technology and making the rules around use is critical. And then the final piece I would say is, as democratic countries, yours and mine, I've worked with so many Australians I deeply respect, wonderful national security community. We are in many cases up against adversaries far less constrained, who don't particularly care about civil liberties and privacy. Whether you look at the Iranian government mowing down its own children protesting in the streets, or whether you look at millions of cameras in China trained to have sophisticated facial recognition models, we should always remember that what we're doing is protecting our way of life. So while competing with those countries and ensuring AI is useful in that competition and fight, we also want to ensure every single American feels confident that that technology is used in a way that reflects the civil liberties and privacy that makes our country so unique. So ensuring that enough is shared in that, so the average educated American feels that way is key. And that was my biggest takeaway from the failure pre-Snowden, was that the intel community was a black box. People didn't understand how it operated. The intel community didn't do enough to convey that in ways that protected sources and methods. So those are the three takeaways: roles and responsibilities, a regular way so that there is a deeper technical understanding about what works and what doesn't, and a recognition that we do need to compete with adversaries using these technologies without care, but remembering who we are and ensuring our democratic constituents understand it too.
That's that's a great answer, and I'm glad that we have convenings like this that start to try and bridge that technical divide with the policy divide and make it one unified community. I'm keen to hear more in terms of if you think there's really high-value options to increase this collaboration, that we could be doing more of, both from the industry perspective, the researcher perspective, and the government perspective.
I think the KC and AICS in the US are important elements because they bring together people who understand concerns around national security areas with the frontier labs. I think, the talk we had earlier, and a shout out to Chris Meserole and the Frontier Model Forum, because that can also do convenings there so that across the labs there's more commonality. I will say just a key point on concerns regarding the Department of Justice and antitrust concerns. After China compromised large numbers of telecom companies, I convened a group in the Situation Room at the White House, and the Department of Justice affirmed that companies working together to ensure the cybersecurity and the trust and safety of their products do not have antitrust concerns, because generally there's a larger national interest for them working together. So I would encourage, and frankly, we see it in banking, we see it in the healthcare sector, where there's regular gatherings of ISACs, information sharing analysis groups, that come, share information actively, work on trust and safety efforts. So anyone who has concerns, I encourage us asking the Department of Justice or conferring with those sectors that do it successfully each and every day, because from my experience, it is not an issue, although it appears to be a concerning one. The Department of Justice has said repeatedly it's not one. So I think that removing that barrier that I think some feel, and this was particularly important in sectors that have had high amounts of regulation like telecom. So even in that sector that has had large amounts of telecom because of concerns around companies working together, setting prices, et cetera, the Department of Justice said, no, we need you working together. You have shared vulnerabilities and a need for shared resilience.
I do want to go deeper on this cyber AI intersection. So we're now seeing agentic AI systems that are often acting in ways that weren't intended. And we've also seen uh, new novel ecosystems like Maltbook, the social media for agents, and then Conway, which gives agents the ability to spin up their own cloud services, get crypto wallets, and self-replicate. It seems like a lot of these initiatives are being created by tech enthusiasts at the frontier, but not necessarily with deep consideration of security implications. Now, you've stood up the NSA's Cybersecurity Directorate. You've got a lot of experience in these issues. And so, what prior episodes should we be paying attention to inform how we think about what's coming next? And what do we need to be doing now to prepare?
The agentic wave is super interesting in terms of enabling AI to just do a lot of interesting things both in our day-to-day work. I think what we want to watch for is when agents start working with other agents and ensuring that agents' work follows the intention and stays within the intention of the initial human request or process that kicked it off. So in cybersecurity, we've now spent the last 5 to 10 years dealing with implementing human identities, role-based access controls, ensuring that individuals are doing role are have their access really shaped by what their role is, and trying to monitor to see, is there an anomalous use that could be the first signs of a malicious use? Quite frankly, AI-based agents could set us back 2 decades in terms of suddenly having lots of non-lockdown identities doing lots of things on a network, interacting with each other, and potentially kicking off physical actions when we think about physical AI and robots. The good part is that a lot of what we've learned and implemented with human identities, role-based access controls, monitoring for anomaly can be done in the context of agents and digital identities. So I think really porting that, ensuring that my own view is every AI agent is synced with the same set of controls we would have used for a human agent on what is the role, what is it permitted to do, does it operate, for example, in a sandbox, what kind of sensitive data does it have access to, is important. Because otherwise, I think the trifecta of potentially remote access, sensitive data, and kicking off activities that may then do things that may not have been intended could cause some unforeseen harmful impacts.
And we've had a few questions coming from the audience, and just a reminder that we're using Slido for questions, so please feel free to submit them. Um, Staying on the cyber topic, the DARPA AI Cyber Challenge was well received by the community. Um, do you see new opportunities or similar opportunities for grand challenges in AI today?
Absolutely. So what worries me a great deal, I was talking with a number of individuals this morning about what could be an effort that would address it, is so I think we're going to see a wave of AI-driven cyber attacks because it's far easier to find 0 days and it's far easier to find misconfigurations and gaps. I am one who firmly believes AI helps a ton on cyber defense, and indeed the delta on cyber defense, I believe, is far more than on cyber offense if people act, because cyber defense is still a fair amount of manual work, bringing together lots of different data, and there's always a fear of false positives. That, for example, an account that's doing something anomalous and odd, you shut it down and you discover, well, the CFO was negotiating a deal in another country in the middle of the night. You've just shut down their access, right? So I think as a result, AI on cyber defense can be a game changer, but I worry about this wave of attacks. One thing I learned from the years in the White House. So in my years in the White House, whenever there was a major cyber attack, the president made clear he expected the NSC to run it, right? So the phone would ring and be like, what are we doing? Because disrupting infrastructure in the US, while these systems are privately owned and operated, the average American expects their water to be clean, their power to be on, and their air traffic control to be safe. So I think one of the things that would be really interesting to your point about the DARPA, what made the DARPA AI Cyber Challenge was so interesting that it wasn't just find vulnerabilities. Companies have more vulnerabilities than they have time or effort to do it. It was use AI to actually patch them. Can you create a closed system that finds and fixes? And if so, that's powerful. And that's finds and fixes on code, and it's finds and fixes on systems. So I think bringing the third part of that triangle to digital twins of national infrastructure where we could have cascading failures and saying, can we create a digital twin of a water system and then actually do that, find and fix vulnerabilities at scale, can potentially be the game changer in our national infrastructure And we are far more vulnerable than countries like China that have national firewalls that aren't concerned about monitoring private sector systems. So it could also have positive geopolitical impact.
That's a good take. On that, actually, diving in, you talk about that companies have more vulnerabilities than they know what to do with and have time to deal with. One of the questions we often have come up is like, what is the role of government in securing? Um, we've got some consensus on critical infrastructure, but as AI data centers emerge as increasingly critical digital infrastructure, given that they underpin the most advanced AI models, what do you see as the government's role there? Like, is there a role for the NSC or the NSA in helping strengthen and harden these systems against malicious foreign actors?
Yes. So here's where I think there's consensus. Here's where there isn't. I think on the consensus piece, when I served at the National Security Agency as part of the Cybersecurity Directorate, we stood up the first ever NSA sharing of unclassified information with the private sector, called the CCC, led by an amazing team. That effort continues. So that is where the intelligence community takes upon itself to rapidly declassify and share intelligence information. That needs to be even faster and more regular. And today it was constrained to focus just on the defense industrial base. I think we could argue that given that AI models are used across the national security community, they can be part of the defense industrial base and receive the benefit of that intelligence sharing. There are some legal issues around what's permitted for foreign intelligence agencies to do to protect domestic companies that get U.S. persons protections. I won't go into those details. Happy to do so offline. But that first piece is sharing threat information regularly and quickly, including that focused on specific companies. I think the second piece is the national security community has modeled various kinds of threats. So we may know about certain advanced adversary techniques, which can't be shared more publicly at this moment because the sources and methods are sensitive. But as a result, when the agencies then release cybersecurity advice or guidelines, conveying to companies, look, there's an active threat technique we know about, this addresses it, is a second way. I think there's agreement on that. And these are generally back and forth conversations, right? The frontier labs know the models the best. They know what they're capable of in terms both on offense and defense. So having that conversation with individuals who may be deeply technical in particular fields like cryptography or vulnerability analysis is useful. I think the third part where there probably is more controversy is what should be required. Having worked at the White House for a number of years, it was continuously surprising to see how companies who we rely on each and every day weren't necessarily making the cybersecurity improvements. Like, think about model weights. Are we all confident that the frontier labs are protecting model weights in the way that absolutely must be done, given the high level risk, given you have the best intel services in the world probably pursuing them? I don't know. But I think in many cases, making those kinds of sophisticated cybersecurity practices mandated for the most sensitive infrastructure is needed. The last administration, we put it in place for airports, for ports, for pipelines, for energy systems, because we saw that absent that, they were not in place. And I think it's a fair discussion to have if for the labs, models are this important to our economy and our national security. Having that mandated, in my view, is a wise approach that should have buy-in because it ensures that the best protections are in place when we know they're pursued by the best and most capable hackers around the world from countries that are competitors and adversaries.
Speaking of competitors and adversaries, we have a question here about should the US government ban open weight Chinese models for tech as a tool, government use, or for national security use?
Should they ban open source for
Chinese open
Chinese
source
open source
models for
for?
government use and critical infrastructure use?
Yes. I don't have confidence. Open source is fine. Given we don't have transparency on how those models are trained, and given in some cases we don't know what kind of prompt engineering with remote access could do, I think it's concerning and unwise to bake in technology at a foundational level that you fundamentally don't have confidence in, or can't have confidence in, is a better way to put it.
Um, it's an
This is from me, who generally does not like bans because I often feel they're hard to actually enforce. And if you can't enforce a ban, it's security theater. But in this case, I think it would be highly unwise. So, yes.
Another question that goes back to the Anthropic Pentagon dispute was around AI can really help carry out effective surveillance. But how do you think about appropriate guardrails, particularly as we think about what new privacy preserving capabilities AI might be able to offer the intelligence community?
So first, I think it's very important to say that one of the purported Anthropic requests, which is no domestic mass surveillance, I can tell you this is somebody who spent almost 15 years at the National Security Agency and can give chapter and verse on the Fourth Amendment and all the minimization rules and everything else. Domestic mass surveillance in the United States is not permitted. Now, there is a distinction made between collection of information and purchase of data from commercial data brokers, because the view is this data is broadly available and can be used for the kinds of threats that the largely law enforcement deals with, which is, frankly, finding lone wolf actors, those hiding in civilians, needle in a haystack. You need some analysis of a haystack to find that needle. Otherwise, it's near impossible, right? And frankly, we've had a number of lone wolf attacks that I would say the law enforcement community missed, because this is such a fraught area. How do you protect civil liberties and privacy, which is goal number one? How do you keep people safe, which is goal number 1B, right? So in that context, I think it's important to make that clear that mass surveillance in the United States is not permitted. In that way, exactly to the question, when I think about targeting outside the United States, particularly in the context we see with terrorist groups like Hamas, like Hezbollah, that intentionally hide among civilians, those are tough problems for militaries and democracies. AI can be helpful in more precise targeting, finding the combatant dressed like you and me, hiding among civilians, and ensuring that the impact on civilians around that is as narrow as possible in line with the laws of war. So I think AI can be more helpful in precision in that way.
You also mentioned recursive self-improvement as one of the risks that you're worried about and grappling with. And from your position, having sat across both the public sector and the private sector, how should there be greater collaboration and engagement on these risks going forward? Do you think that more regulation is needed, more information sharing? And do you have any views as to what progress looks like in that space?
This is such a cool group because I love the title, technical innovations for AI policy. Too often those two worlds, there aren't enough bridges between technology and policy. And really the best way to ensure enforcement of the policies we have in place is technical, right? Because that way you know that you're using data to enforce policy. So this is a great example of, recursive self-improvement is exciting. We want to know where a degree of self-improvement leads to capabilities we worry about. So for this group, right, what are the technical attributes of recursive self-improvement that we should be monitoring to understand if emerging capabilities are dangerous and worrying? Is it energy consumption? Is it guardrails that are crossed? Is it actual testing, giving instructions and seeing what comes back in a way like we've seen with certain cyber capabilities where, agents did things that were unexpected? I think that's an area where further research is very much needed. So we figure out, exactly to your question, what are the technical attributes we can be monitoring in recursive self-improvement that become informative to let us know that we've crossed some threshold of concern.
Related to this, so we're in a room and we're at a conference that is filled with people in the policy community, research community, government, private sector, who are all deeply committed to making the AI transition go well. From your vantage point, what do you think are the big open technical questions that people should be turning their minds to? And what are the open areas of science that you'd like more attention on?
So on the first, I would lift up two. One is physical AI is really exciting. How do we validate that physical actions taken in the physical world, actually match what was intended by the model, by the instructions? How do we simulate and model that to ensure that we have the confidence that what happens in the physical space actually meets, particularly when you have potentially multiple agents interacting with each other, right? It's exciting to think about world models and the role of simulation in further training models to be more precise and to do various activities. I think we need a better understanding of how that circle closes. That's one. The second is we're seeing a wave of code, which is exciting because of coding agents. For all of us who've worked on, I've had the privilege to work both offense and defense. Offense is so much easier. It's so much easier to be the attacker. What do we do? What do we need to do to ensure that this wave of AI generated code is built with a lot of the security rules we know built in? And there's been really exciting efforts at OpenAI, at Google, at Anthropic to build in some of this, but it needs to become routine. Cisco has open source efforts, and when people are coding whatever models they're using, it bakes in some of the secure processes. Similarly, how do we make that the default? Shift it to make it the default, because I think we have the opportunity to. Today's digital infrastructure is so fragile. One only needs to look at the latest cyber attack to see that. I think AI can be transformative in changing that. It must be, because otherwise we will have a wave of more use in digital without considering that. I think the third area is partnerships in fields that can and we must have innovation, like drug discovery, like operations of hospitals, areas that are accident prone, and building that trifecta of people who understand those processes and the rules in that space, people who understand AI well, and actual implementers, so that we modernize and update the regulations and approaches in this country. So we're leveraging the innovation, but building updated, modernized guardrails to account for what's possible with AI in a way that drives our economy forward. I think people are scared about AI today, understandably, and it's the role of folks in tech and policy to build the guardrails, which we haven't done successfully, as I think we'd all agree, whether it's social media, whether it's cyber. Tech moved out. We see the harms playing out in society. And I think the role of technologists and policymakers today, as we see the promise of AI, to build in the guardrails for human trust, for physical accidents, and for the capabilities, that's the call to action for this group. And I think why I feel privileged to be here today. And I think that's the most important thing we need to do.
Fantastic. One thread I wanted to pull out from that was around this. The AI cyber intersection is getting a lot of attention as like the domain in which we're most likely to see significant threats emerge first. I've heard many discussions on the question of, is it offense, defense balanced? And you've mentioned like that it can be a great tool to defenders. One of the open questions I have, and I'm not sure if this is a question that many folks have a clear answer on, but would love your views on, is whether it is possible to actually, with enough investment and effort, make secure code and make secure systems, or if there's always natural fragility that comes in when systems are interacting. I think for me, that's like one of the key questions on which it like hinges as to whether this is going to be, AI is going to be massively defense dominant or also still offense dominant.
So, with 1 minute left, I don't know if we have time for a formal methods debate, but what I would say is the three things we can do today on defense would be A, let's just start continuous red teaming, find and fix for the most sensitive internet connected systems. A. B, using AI to find and fix vulnerabilities in all new code we generate. And 3, for the most significant infrastructure, our largest hospitals, our energy grid in biggest cities, our air traffic control in our biggest cities. Let's create, not physical digital twins where we replicate every single router, but digital ones, simulate attacks, and then figure out the high impact things to make those systems less likely to have cascading failures. I think those 3 things are achievable technologically today. And in parallel, we can have the formal methods debate.
That was such a wonderful, succinct answer to a very complex question. Please join me in thanking Anne Neuberger for joining us today.
Thank you.